My name is Shagufa Azizi, and in this talk, I will discuss how we can benefit from self-supervised learning methods for medical image classification. This work was carried out at Google Research. Traditionally, the successful development of deep learning algorithms depends on the availability of large annotated datasets, where transfer learning has been a prevailing paradigm for medical image analysis and beyond. Recently, self-supervised learning methods have demonstrated success in many applications, being able to learn representations without labels to produce pre-trained models that are being used further in the pipeline for subsequent fine-tuning using the label data. The most competitive methods for learning representation without labels are contrastive learning methods. These methods learn representation through a contrastive loss which pushes apart dissimilar pairs while pulling together similar data pairs. While there have been several recent efforts to use self-supervised learning in medical domain application, in this work, we study self-supervised learning as a pre-training strategy for medical image classification. In particular, we evaluated the effectiveness of these methods in label efficiency and domain generalization as two of the most important problems facing the field of medical AI. Our approach includes three steps: self-supervised pre-training using unlabeled natural images, then an additional self-supervised pre-training using unlabeled domain-specific medical images, and finally, supervised fine-tuning on medical images with labels. We also propose multi-instance contrastive learning, MICLE, with generalized contrastive learning to leverage a special characteristic of medical image datasets. When multiple images from the same pathology are available, MICLE enables generation of realistic augmentation to create more informative, positive pairs and further boost the performance. We conduct experiments on two distinct tasks: dermatology condition classification from digital camera images and multi-label chest X-ray classification. Each task includes domain-specific unlabeled data, a labeled dataset, and the additional out-of-domain dataset which has been collected in different medical settings. Our results suggest that self-supervised pre-training, which uses unlabeled domain-specific medical images, could significantly outperform supervised pre-training, the standard protocol for training medical imaging models. Our dermatology condition classifier achieves a sizable gain of 7% in top-line accuracy, even in a highly competitive production setting. We also evaluated our method without any further fine-tuning on shifted datasets. We show that self-supervised models are robust and generalize better than baselines, where pre-training using MICLEs leads to the most gains. Moreover, by fine-tuning using varied size of labeled fraction, we show that self-supervised models can reach supervised baseline using only 20% of the training data, and are significantly performing better in low data regime. To summarize, our study suggests superiority of self-supervised learning for pre-training in medical imaging models, resulting in better generalization and label efficiency. We recommend all practitioners building medical imaging classifier to consider using self-supervised pre-training. Thank you.